Hello, Coach Holmes here, and today we're going to talk about similarity, which basically means we're talking about similar figures, okay? And so what we're trying to do here is that we're trying to make sure we actually have similar figures because of a dilation. So what is similarity exactly? It is preserve the same shape but not size, okay? So if it has a similar shape to it, if the shape is similar but the size are different, then it's a similar figure. And we'll actually get a lot of similar figures when it comes to dilation, because that's what dilation does. It preserves the shape, but the size will be different because we're making it bigger or we're making it smaller. So here's a couple examples as far as being able to preserve shape but different size. And we're going to do transformations with these two. So I have a translation for the first, dilation for the second. So I'm going to translate the figure first. So for example, I go to the right 2, down 4. 1, 2, 3, 4. So here's Z prime. X, I'm doing the same thing. 1, 2. And then right here. 1, 2, 1, 2, 3, 4. Okay? Okay? So that's the translation. Next thing I want to do, that's not what I want. Next thing I want to do a dilation. So remember, if it's 2x, 2y, that means my scale factor is 2. So I'm going to multiply both x and y by 2. So this is 2, 2, which means I'm doing 2 times 2, which is 4. 2 times 2 is 4. So I have C double prime at 4, 4. Now this right here, 1, 2, 3, 4, negative 4 times 2, which is negative 8. 2y, 2 times 2 is 4. So my x double prime is at negative 8, negative 4. And then y prime, x is 0, so 2 times 0 is 0, so that doesn't change. But since it's 1, 2, 3, 4, 2 times 4 is 8. 5, 6, 7, 8. Okay? Now, notice how the green is a similar shape to both the red and the blue, but it's different size. So that's a similar figure right there. So we have a similar figure where the green is the same shape, but it's twice the size. Okay? Next, we're going to do a rotation at 180 degree counterclockwise with a dilation of 1/3. So remember, with counterclockwise being the rotation of 180 degrees, I change the sign for both values x and y. So I make it so really, since both x and y are positive, I make them both negative. So this is 9, 6. 1, 2, 3, 4, 5, 6. 9, 9, which is negative 9. And then b prime is going to be 3, 9, which is negative 3, negative 9. So the next thing we got to do is we got to do a dilation of this figure, which is 1/3. So we're doing a dilation with 1/3. So since I know that A is 9, 6, negative 9 divided by 3 is negative 3, divided by negative Negative 6 divided by 3 is 2. Let me put that in green though. Now C prime is negative 9, negative 9. You divide both of them by 3, we get negative 3, negative 3. And this right here, B prime is negative 3, negative 9. Negative 3 divided by 3 is 1. Negative 3 divided by 9 is, 3 divided by negative 9 is negative 3. Okay? So again, similar figures, but it's divided by a third. So it's a third of the shape for these triangles. Okay? So we still preserve the similar shape. We preserve same shape, but different size. So we still have similarity. Next, we want to describe the transformation. So this one's going to be a little bit easier for us because we have B right here, B prime, and C prime. Okay, so we can, so at least we have the map showing us. We know what the direction is going. Now, just by looking at it though, do we know if it's similar or congruent? Well, let's find out the transformations. So first off, so I want to go from here to here, which means it looks like it's a translation because it's the same direction. So I'm going to go 1 unit to the left. So it's a translation. So it's a translation where it's x minus 1. I go down 1, 2, 3, 4, 5. Okay, so far still congruent because translation doesn't change the shape. It doesn't change the size, it changes the location. Just like reflection and rotation. Now looking at it, it looks like to me it's reflecting across the y-axis. Because if I count, because notice how the x values are different when it's reflected across the y-axis, but the y values are still the same. So this is a reflection across the y-axis. Since there is no dilation that gets us here, we still have congruent figures. So this figure is not similar, they're just congruent. Okay? So that's one of the things we may have to recognize is that sometimes the figures aren't really similar, they're just literally congruent. Because any sort of transformation is either going to give you a congruent figure or a similar figure. Either or. And really the only way we get similar figures is through dilation. Thank you and have a good day.